All right, everybody. So for the next ones, we're going to use these trig ratios, okay? And then again, what we want to notice is one, it's a right triangle, and we're finding a missing side length. But because we only have one measure, we can't use the Pythagorean theorem. And then also, these are not special triangles. It's not a 45-45-90 triangle, and it's not a 30-60-90 triangle. And this angle here lets me know that. Same thing, like this angle lets me know it's not a 30-60-90 triangle or a 45-45-90 triangle. Okay? So when we solve these, if you need to pause it to copy this down, go ahead and do that. But when we solve these, this is what I like to do. So first I identify what, like, an angle I have information about. And then identify the sides I have information about. Like this side is across the 44-degree angle. Because it's across the 44-degree angle, I know it's the opposite side. And then this side, which is x, is across the 90-degree angle. So I know this is the hypotenuse. Okay? And then down at the bottom side is actually the adjacent side. But I don't like to put the adjacent side in there because I have no information about that. So to me, I'm like, let's not even identify it because there's nothing I know about that side. So I'm going to leave that one blank. And then I look over here at the ratios, and then I'm like, okay, well, which ratio uses the opposite side and the hypotenuse side? Well, that's this one. Here's the opposite side, and here's the hypotenuse. So I know the ratio I'm looking for is the sine ratio. So sine of A, I'm just going to rewrite this, equals opposite over hypotenuse. And then I look at my diagram to fill in this information. A is representing an angle. Here's the angle, it's 44 degrees. So sine of 44 degrees is equal to the length of the opposite side, which is 17, and then the length of the hypotenuse, which is x. Okay, and then remember, when we solve these, I like to set it up as a proportion and then solve the proportion by cross multiplying and dividing. Okay, so I know x is equal to 1 times 17 divided by sine of 44. And I don't need to figure out the value of this. What it's asking for is an equation that can be used to solve for x. And this can be used to solve for x. Now the only difference is, see how this is 1 times 17? We all know 1 times 17 is just 17. So I'm going to just have 17 on top. Okay. And if I needed to find the decimal approximation of this, I could just type it in the calculator. Like, that's not difficult. So let's go and look at number 5. So if you look at number 5, again, it's not a special right triangle. I can't use the Pythagorean theorem, so that means I'm going to have to use one of these trig ratios to solve for the missing side length. That's the angle, that's the opposite side, this is the adjacent side, and then this over here is the hypotenuse. But again, I'm not going to write in hypotenuse here because I don't have any info on it, so I'm not going to use it. So then I look over here at the trig ratios and ask, well, which one uses opposite and adjacent? Well, that's this one. Tangent uses the opposite and the adjacent side. So it looks like this. Tangent of angle A is the length of the opposite side divided by the length of the adjacent side. Now I'm going to look at my diagram to fill everything in. A is 54. Again, that's the angle measure. Opposite length is x. Adjacent length is 17. Write this as a proportion. Cross multiply, so you don't grab the letter, and divide by what's left over. So the equation is 17 times tangent of 54 divided by 1. Now again, like the times one, whenever you divide it by 1, you always get that number back. So actually you could just knock that 1 off. And then this is just the equation here. Right? 17 times tangent of 54. And I say that because, let me show you an example. Like technically we could write 9 divided by 1, but nobody does, we just write 9. Same thing with like 10 divided by 1. Well, nobody writes it that way, we just write 10. So right here where I had this divided by 1, we don't write it that way. We just leave the divided by 1 out. Okay, so that's why I didn't put the 1 underneath. Or that's why I take it off. And then if you look at 7, again 7, it's not a special right triangle because this is 65 degrees. And I cannot use the Pythagorean theorem because I only have one side measure. So that means I got to use one of these trig functions or these trig ratios over here. This is the angle. That's the side opposite the angle. So this is the opposite side. This side is opposite the 90 degrees or across the 90 degrees. So that's the hypotenuse. And again, opposite hypotenuse is sine. Okay, so I'm not going to write the ratio this time. I'm just going to say sine of the angle, which is 65 degrees, is equal to the length of the opposite side, which is x, divided by the length of the hypotenuse, which is 14. Set it up as a proportion, cross multiply, divide. So this is x equals 14 times sine, that's sine of 65 degrees, divided by 1. But again, we don't put in the divided by 1. And that's sine. Okay. Pause it, rewind it if you need to. I'm going to keep chugging along. And the only difference between these three and the three I just finished is for these three I am going to actually type it in the calculator. Again, here's my angle. This is the opposite side. This is the adjacent side. Opposite of adjacent, if you look over here at the trig ratios up top, that's the tangent. Tangent of angle A is opposite over adjacent. Okay, so the angle is 17. The opposite side is 12. The adjacent side is x. Cross multiply and divide. Now I'm not going to rewrite this. I'm just going to type it into the calculator and show you what I get. So watch. 1 times 12 is equal to 12. That's why we don't like to write the 1 times. And then it's 12 divided by this tangent of 17 degrees. Oh, I didn't do the divided by. 12 divided by tangent of 17 degrees. 39.3. Be careful, make sure you type when you're pushing the buttons that it does go through. Like a second ago I just typed it in and it didn't go through. But anyway, that's 39.3. Same thing here. Here's the angle. That side's opposite. This is the hypotenuse. If you look at the ratios, that sine is opposite over hypotenuse. So sine of 64, because that's the angle. The opposite side is 20. The hypotenuse is x. Let me scoot that over. Put a 1 under it. Cross multiply. Divide. Again, 1 times 20 is just 20. Okay, 1 times 20 is just 20. So then you have 20, and that's divided by, again, make sure you put divided by 20 divided by sine of 64. And that is 22.3. Okay. And the last one on this section, that's the angle. This is the adjacent side because it's right next to the 40. This is the hypotenuse because it's across the 90 degrees. This one is cosine. We haven't seen cosine yet. Cosine is adjacent over hypotenuse. So we have cosine of the angle, which is 40, is equal to the length of the adjacent side divided by the hypotenuse. Put that over 1. Cross multiply and divide. That one looks like this. 11 divided by cosine 40. 14.4. Pause this, rewind it, copy it, get it.